Welcome to the DIY Honda Garage channel. The DTC codes P0120-16 and P0122 indicate a problem with the throttle position TP sensor A circuit, specifically relating to low voltage output. The TP sensor, which is integrated with the throttle body, monitors the position of the throttle plate and sends that data to the powertrain control module, PCM. The PCM uses this information to manage the fuel injection and ignition timing for effective engine performance. If the voltage from the TP sensor falls below a specified threshold, typically less than 0.3 volts, the PCM identifies this as a malfunction and triggers the DTCs. The faults may also involve other related components, including the PCM itself and associated wiring. Thorough troubleshooting is necessary to pinpoint the exact cause, which may include both electrical and mechanical issues within the throttle body area. The DTC P0120-16 indicates that the throttle position sensor A is reporting a low voltage condition. This sensor is integral to the throttle body, located within the intake manifold, and is responsible for measuring the angle of the throttle plate. It communicates this angle to the PCM, which adjusts the engine's fuel delivery and ignition timing accordingly. When the sensor voltage is lower than the predefined limits, the system considers it abnormal operation. Consequently, low signals from the TP sensor may adversely affect engine performance, leading to poor acceleration and increased emissions. Understanding both the functional role of the TP sensor and its placement in the vehicle is crucial for effective diagnostics. Several potential causes can lead to the triggering of DTC P0120-16, P0122. A common culprit is a faulty throttle position sensor A itself, which may fail internally or exhibit erratic behavior. Another likely issue can be related to wiring problems, such as frayed or broken connections, particularly in the circuits associated with the sensor. Additionally, the powertrain control module, PCM, which processes the signals from the TP sensor, may also malfunction, leading to improper readings. It is crucial to systematically investigate each of these components as part of the troubleshooting process to effectively resolve the issue and prevent future occurrences. The symptoms associated with DTC P0120-16, P0122 manifest primarily through performance issues in the vehicle. Drivers may experience poor acceleration as the engine struggles to receive the correct fuel-air mixture due to inaccurate throttle position feedback. This situation often leads to increased emissions, violating environmental standards and potentially causing the vehicle to fail emissions testing. Additionally, the check engine light will illuminate on the dashboard, alerting the driver to the presence of the DTC. It is essential for vehicle owners to address these symptoms promptly, as they may not only affect performance, but could also lead to more severe engine problems if left unchecked. For the first step in troubleshooting DTC P0120-16, begin by turning the vehicle ignition to the on position, ensuring all electrical systems are activated. Using the Honda Diagnostic System, HDS, monitor the TP sensor A value displayed. A normal reading should be about 5.0 volts, indicating that the sensor is functioning within expected parameters. Conversely, if the reading is less than 0.3 volts, the fault is confirmed. Accurate measurement is critical in assessing whether the malfunction resides within the sensor or linked components. Subsequent steps will rely on the outcome of this first inspection, guiding the direction of further diagnostics. In the second troubleshooting step, start by disconnecting the throttle body connector, the 6-pin connector responsible for relaying signals from the TP sensor. After disconnection, check the voltage output from the sensor with the HDS. Under normal conditions, the output voltage should read approximately 5.0 volts. If this value is confirmed, it indicates that the throttle body is functioning correctly, driving the next steps in the inspection towards circuit-related issues. However, if the voltage is still found to be abnormal, concerns may then shift to sensor wiring or the sensor itself. This methodical evaluation ensures accurate diagnosis and efficient resolution of the fault. Following the voltage output inspection, proceed to evaluate the electronic circuits linked to the throttle body and TP sensor. To conduct this circuit inspection, first, ensure that the throttle body connector remains disconnected before starting. This thorough inspection involves checking the VCC3 circuit, which is responsible for supplying voltage to the TP sensor, THL1 for signal transmission, and the SG3 ground circuit for any faults. By measuring resistance values as specified in the manual, any discrepancies, such as shorts or open circuits, can be detected. The results of these measurements will clarify whether a wiring issue exists, guiding further diagnostics toward either the wiring or PCM. In the final troubleshooting step, the emphasis shifts toward the powertrain control module, PCM. If previous inspections indicate expected normal conditions for both the TP sensor and its related circuits. At this stage, if there is no sign of failure in either the sensor or wiring, the PCM must be scrutinized, as it may be the root cause of the DTC. Performing diagnostic checks on the PCM involves confirming proper function and examining the internal processor for errors. If the PCM is found defective, it will need to be replaced or reprogrammed to restore correct throttle position signal processing. This concluding step is crucial for resolving the DTC permanently and ensuring reliable vehicle operation. Upon completion of all repairs based on prior troubleshooting actions, it is essential to verify that the problem has been resolved. Start this process by clearing any stored DTC codes from the PCM. Afterward, conduct a thorough inspection to ensure that the throttle position system operates correctly according to specifications. A crucial component of this verification includes taking the vehicle for a test drive under various conditions, monitoring throttle response and performance. If the check engine light does not reappear and vehicle operations remain smooth, the resolution can be considered successful. This final step ensures that all concerns have been adequately addressed, reinforcing confidence in the repair quality. Preventive maintenance plays a vital role in avoiding future occurrences of DTC P0120-16/P0122. Regular inspections of the throttle position sensor and its wiring harness can catch faults before they lead to failure. Look for signs of wear, corrosion, or damage in the connectors and wiring, which could compromise the system's integrity. Additionally, ensuring that the powertrain control module is updated with the latest software can help in optimizing performance and enhancing diagnostic capabilities. Routine maintenance not only prolongs the lifespan of these components, but also contributes significantly to overall vehicle reliability and performance, ultimately saving costs and preventing inconvenience. In summary, understanding the role of the throttle position sensor A is crucial in diagnosing DTC P0120-16 and P0122 effectively. Following a systematic troubleshooting approach enables accurate identification of faults, whether they stem from the sensor, its wiring, or the PCM itself. As highlighted, it is essential to verify repair outcomes to ensure that the issue has been definitively resolved. Implementing preventative maintenance practices will also help safeguard against future issues and maintain optimal vehicle performance. By prioritizing these strategies, Honda CR-V owners can ensure longevity and reliability in their vehicles. Please like and subscribe to the channel. See you next time.